In this video, we're going to construct a hexagon given its side-to-side length. So there's two ways to kind of approach this from the beginning. I'm going to show you both ways. The second time I'm going to go through it very, very fast. The first time here I'll go slow. So this first one here, I'm going to give you a side-to-side measure. So let's just say, well, it's going to fit in my paper here nicely. Yeah, 3 inches. Right? I should be able to fit that okay. So on the bottom of my page here, I'm just going to draw a line. Again, this line has no length or anything like that. It's just a line. So now if I give you a 3-inch side-to-side measure on this, what I want to do is I want to set my compass up to that side-to-side measure. Okay, just getting my color installed here. I'm going to grab my ruler and I'm just going to go 7 to 10. All right, so I'm on the 0.7. Should get back just a bit. So I'm on my 10. That looks pretty good. That's 3 inches. So now I draw a parallel line to this line. That's 3 inches away. So I'm just going to pick a point on this side of the line and draw an arc, and then a random point over here, and do the same and just draw another arc. So now I want to draw a line across there. Now normally all my construction lines are red or some other color, but because this is our side-to-side length, I'm actually just going to draw this in black as well. So this again is just a line. Okay, it's just a line. So now I have a parallel line to the baseline that is 3 inches away, which is going to be the side-to-side measure of this hexagon. So what I want to do now is I want to kind of give myself a midpoint here, or something, kind of a reference point, or a vertical line, if you will, that will be the center, or at least half of the center of the hexagon. So I'm just going to draw a vertical point. And to start this, what I'm going to do is I'm going to pick a point here. I'm not doing any measuring here. I'm just going to say, okay, I'm going to start my hexagon right about here. All right, I'm going to choose that as my vertical point. So now what I want to do is I just want to set my compass up to any convenient radius. All right, anything will do. Right here is fine. So now I just set my compass on that point I created. And I'm just going to step off equal distance on both sides. Okay, so I have a point here now and a point here, which are the same distance away from this center point. So now I'm just going to bisect one side of this line at that point. So now I'm going to set up my compass up to over half the distance. All right, so anywhere over half is fine. I'm going to draw an arc above and an arc above. I don't need to do the one below because I've already taken care of that by doing equidistant from here. So now I connect through this point down through my point, and that will be a perpendicular line to this bottom line. So this I'm going to continue in red. So now from my arbitrary point there that I picked, I can draw a vertical line straight up. Right, and that now is a vertical line perpendicular to these two sides. Okay, because I wasn't specified in my question where I'm going to put the hexagon or anything like that. I'm just arbitrarily picking a center point that I can use, right? So I can just extend that up. So eventually now I'm going to find my center point of this hexagon right here somewhere, just based off of this line. Right? I could have put this anywhere along here. It really wouldn't have made a difference. I still would have been able to draw in my hexagon. So again, I just picked a point and then just put up that vertical line. Okay. So now what I want to do is bisect that vertical line. And that will tell me the center of my hexagon. So to bisect this, I'm going to set my compass up to roughly about 3/4. Right, somewhere about 3/4 of that line. I'm going to bisect from this point here. So I'll put an arc over here and over here, and then I'll bisect from this top point, right? And I'll put a line over here and over here, right? And that's my bisector of that side-to-side measure line, which is 3 inches long from parallel line to parallel line. And now I'm drawing another parallel line here right across the bottom by bisecting and find the exact center here. So right now, the distance from this line to here is going to be exactly the same as the distance from this line to here, which kind of brings me how I'm going to draw it at the end here. So let's say you were given the middle line, and let's say you wanted a hexagon centered on this line. Well, one of your starting points, aside from drawing a vertical line to get center, one of your other things you would need to do is determine, like, if your side to side length is 3 inches, then you'd have to draw parallel lines off of this at 1.5 inches, right? So 1.5 inches from this line up here and 1.5 inches to the line down here, which would give you that overall 3 inches if you were provided the center line where you wanted this hexagon to go. Whereas this problem here, I said, okay, here's this baseline, and we're going to put the hexagon starting at this baseline and then have a side to side length of 3 inches. So it's just a different way to start the question. Okay. So anyway, now that I've found my center point here, what I need to do is basically figure out the side length of this hexagon, right? Or the radius. Because remember, in a hexagon, the radius is the exact same as the side length because it's an equilateral triangle, right? Hexagon is 6 equilateral triangles. So to do that, we have to figure out our side length. And to help us construct that, we already know that the hexagon is made up of equilateral triangles, and we also know that the interior angles of equilateral triangles is 60 degrees. And we also know how to draw a 60-degree angle. So if I take my compass and set it to any radius, right? I don't know what my radius is yet, but I set my compass to any angle, and then if I draw an arc up, so I draw part of a circle, and then I set my point on that intersection line that I have here, and if I offset, if I offset the same compass setting or the same radius, that steps off 60 degrees, right? So now, I'm going to keep going with my green here. I can go from this center point up to this top point. And guess what? Because this is a hexagon, that is now my side length. Because remember, the side lengths of the hexagon are equal to the radius lengths because it's an equilateral triangle, right? So now that I have my side length, this is pretty easy to finish. I'm going to continue with my green here. And now that I have my radius and side lengths, so there's 2 options I could do here. Now that I have my side length set, right, I could just draw the full circle around, or I could just use this and just put marks at every line here, right? Right, so I could just put marks rather than clutter up my drawing. If I just put these marks here, then that actually gives me the 1, 2, 3, 4, 5, 6 connection points for my hexagon. But just for visual, and because I already made a massive arc over here, I'm just going to just show the whole circle there, just so we can see that the hexagon is just inscribed in the circle. So I'll finish this off with blue. And at this point here, all I need to do is just connect all of these points where those circle cross these lines. Right, so connect. And this one here is already drawn in, because remember, we were asked to provide a side-to-side length. So here's one side, and then I have another side down here. And we know that this distance is 3 inches because I offset a line 3 inches. So the side of this to the side of this is 3 inches, which was what we were given. So I just use that information and the knowledge that there are equilateral triangles that I'm trying to draw. And then when I connect these points, that basically now gives me my perfect hexagon with a side-to-side length of 3 inches. And that's it. So just quickly here, I'm going to show you the other way. You know, if you're provided different information or provided a baseline where you want the hexagon to be formed on both, say, top and bottom of it or something like that. So let's start here. I'm going to draw in a 3-inch line. Okay. And again, I could have this 3 line. I'm still going to need to extend it because if I'm given a 3-inch line here or whatever, but I want a side-to-side length from this line. So I'm going to need to offset, which means this side to side length is actually shorter than a point to point length, right? So it really depends. Or I could draw this so my side to side length is here, right? Which would kind of, let's do that instead. It's just another way to do it, because I've already kind of explained the other way. But let's say I want the side to side to be here for this hexagon. So the sides are up and then it goes to the points up there. So, okay, so let's just try that. And then this is my side to side length. So I started with 3 inches and that's going to be my side to side length. Well, the first task we're going to have to do here is draw in our parallel lines at each end of this. And this is simply done just by drawing up a perpendicular. Okay. So again, this is actually still based on the equilateral triangle. So if I just set my compass to any radius, I picked my end point. Right. I just draw up my arc. I step off that twice. And then I bisect between those 2 points. Right. And that will give me my first perpendicular line, which I'll draw in red for now. All right, so there's my first perpendicular line. And now all I need to do is set my compass up to the radius, the side to side length of my hexagon. So setting my compass on one side and extending the radius out to be the other side, I just pick 2 points and I just draw 2 arcs that side to side distance. Right? So now I can connect these 2 lines, forming a parallel line from this one. Right? So now I have 2 parallel lines, and then my line here, which is my 3-inch line that I wanted to draw the side to side length on. And again, I want this one to be oriented so I have 2 of the sides vertical. Whereas in the last one here, when we drew this one, I had the 2 lines horizontal, right? So this one here, just a different type of approach, right? It's the same result though, because I have my 2 parallel lines, right? Which are offset, which is going to be the orientation for my hexagon. And then I have my midpoint line here, which now I got to find the center of my circle, right? So to do that, I'll just switch to orange here. So to do that now, just to find the center of this circle, I'm just going to bisect the original line. So I set my compass up to any convenient radius. That's over halfway, right? And then from one side, oops, compass slipped there. I draw an arc on the top, draw an arc on the bottom, go to the other side, draw an arc on top, and an arc on the bottom. Now you notice these didn't connect. So I just have to, redraw that in until they connect. And then I can draw in my bisector. Okay, so I've cut this center line in half, and now I have my center point. So now from this, again, based on the theory, and I'll do this in purple, equilateral triangle, 60 degrees, and 6 of them make up a hexagon. So again, it doesn't matter which side I pick or which point I do here. I'm just going to pick the center point here and set any convenient radius, right? And because I want the 60 degree, oops, I went from the wrong side there, but because I want the 60 degree angle to come up and hit the side here so I can keep the sides of this vertical, I'm going to draw my arc, but then I'm going to go from this point here to create the 60. Okay, so now I can connect that 60 up here. And connect it through that 3-inch line, and that there is now my radius. Okay, with my 60 degree being here, that means that this is going to fall up here and have a point somewhere up here, which is going to create that equilateral triangle, which also means that I'm forcing the side to be here, which means my sides will be vertical. That's why I switched and went 60 from this point, which means here with this line in the center here, because it's side to side measure, it's going to be 30 degrees on each side of that line. to form that equilateral triangle with the side vertical. Okay? But again, at this point here, it's pretty straightforward. I'll just encompass this in green. So once you have that radius, right? Once you have that center point, once you have that center point to side length marked or discovered, just set my compass up to it. All right, paper keeps moving around. But now once I have that, that is the radius of the circle that circumscribes the hexagon. It is also the side length. So basically where my circle is going to intersect these three vertical lines is going to be the points of the hexagon. So I can just scribe my circle around, and then from that, I'll finish this off with black just because I can. I'm going to start, and this would be one side, a vertical side, and then of course we can connect all the others to form our hexagon. All right, and this one here, I just started a different way. Like say I was given the middle line or the length of the line, so to speak. Oops, me talking and not thinking. I drew the wrong line there, which happens. We all make mistakes. All right. Now in the real world, if I were drawing this for some kind of assignment or something, I would actually restart because that is not a line in the hexagon. The hexagon comes down and it's where the vertical lines hit the circle. I just wasn't thinking. So I have another line there. And then of course I connect where the vertical line hits the circle. But as I said, we all make mistakes. We just gotta work through them, fix them. And in my case, I would redraw this to avoid that mistake there. But just ignoring that line, you can see, of course, that I have my hexagon drawn in and two sides of it are vertical with that initial line given of 3 inches from here to here. And I use that to construct my hexagon.